Hello students, this is Bapaditya Chakraborty, and now today in this video you were watching the YouTube channel Chemistry for Neet, and today's we are live. I'm going to discuss you some reactions, nucleophilic additions reaction of aldehyde and ketone, and after then we will see the reaction mechanism of aldol condensation and Cannizaro reaction, along with short tricks to write the reaction of aldol and Cannizaro, or to write the products of aldol and Cannizaro in a very small time. Okay, so let's start with the nucleophilic addition reaction of aldehyde and ketone. First of all, aldehyde and ketone both have a common thing, both have C double bond O group in their molecule. Now this C double bond group, carbon oxygen is more electronegative than carbon, so the bond pair electrons are shifted more towards the oxygen atom, giving rise of some partial negative charge on oxygen atom and some partial positive charge on this carbon. So this is a nucleophilic center where a nucleophile can attack. Now what is a nucleophile? Nucleophile, phile means love or attraction. Nucleo comes from nucleus, nucleus means a positive charge. So the species which having a love or attraction towards a positive center, nucleus or a positive center, is called a nucleophile. So a nucleophile must must be an electron deficient species, must be electron rich species which can attack to a positive center. So a nucleophile must carry either a negative charge or a lone pair electrons. Okay, so let's see what happens with acetaldehyde. Here I am writing CH3 and here is H. So a nucleophile, in a nucleophile, say if we react acetaldehyde with HCN, hydrogen cyanide, HCN will dissociate into H plus and Cn minus. So the Cn minus here is the nucleophile which will attack to this nucleophilic center or carbonyl carbon. So when it attacks to carbonyl carbon, carbon cannot make more than 4 bonds, so one of the pi bond has to be broken. So this pi bond will be shifted towards oxygen atom, and this effect is called electromeric effect. Okay, so this effect is called electromeric effect in presence of a nucleophile. When a nucleophile attacks to a carbonyl carbon, the pi bond breaks to more electronegative. This effect is called electromeric effect. Now what happens? Cn is bonded to carbon and oxygen having a single bond with carbon, with the carbonyl carbon, CH3, single bond C. Cn comes here, and then here is hydrogen, and here O minus is present. Now this H plus, which is produced from the dissociation of HCN, that H plus will be abstracted by this O negative, and the final product is CH3, CH, here OH, and then Cn. This compound, where with the same carbon a OH and a Cn is bonded, this compound, this type of compound is called cyanohydrine. The compound is called cyanohydrine. So this is with aldehyde, and if you take ketone, here CH3 will be there instead of hydrogen, then here also the CH3 and here also the CH3. So the difference is that in the both sides a methyl group is present, but still it is OH and Cn that are present at the same carbon. So the compound still is called a cyanohydrine compound. So this is the nucleophilic addition reaction of carbonyl carbon. Now what happens when CH3 C double bond O H is treated with say hydrazine, NH2 bond NH2. Okay, what happens when acetaldehyde is treated with hydrazine? The mechanism is that CH3CH. This is not the mechanism I am telling you. This is a short trick to form the compound H2. NH2 will be written as H2N and then single bond NH2. This is still hydrazine, and here oxygen and hydrogen is eliminated, and the double bond continues to this nitrogen, giving rise of this product CH3 CH double bond N single bond NH2. Type of product is called hydrazone. Okay, so this is the short tree, and if any groups are there, the main reactant is this NH2 group and it remains undifferent. Okay, so if you keep CH3 CHO with ammonia NH3, NH3 will be written as H to N, then H. This is also NH3. So here also oxygen and hydrogen, that is water, is eliminated. So water is also produced, water is eliminated, and the product is CH3. Then when NH2 group is bonded with an alkyl group, the compound is called amine, and when NH double bond NH is bonded, the compound is called imine. So this is a imine compound, IMINE, imine compound. So this is the examples of nucleophilic addition reactions where all of the nucleophiles, here Cn minus is the nucleophile, and here NH2. If you see the mechanism, the nitrogen, the reaction is initiated by the attack of nitrogen, attack of lone pair of nitrogen to the carbonyl carbon, and the reaction proceeds. So we are not going to that mechanism, we are just having this tricks and to make the product in very short time. Okay, so this is nucleophilic addition reaction. Now let's see what happens when an aldehyde or ketone is treated with a Grignard reagent. Grignard reagent, this is also an example of nucleophilic addition reaction. Okay, so what is Grignard reagent? Grignard reagent is alkyl magnesium halide. Halide means any halogen, the negative ion of halogen, that is, it may be chloride or bromide or iodide, and the alkyl group may be a methyl group, maybe a ethyl group. Okay, and phenyl group can also be happen, where aryl magnesium halide is also called a Grignard reagent. So when methyl chloride or methyl bromide is treated with magnesium, magnesium being electropositive will lose electrons, lose 2 electrons to form Mg plus 2 ions. Okay, so magnesium will lose 2 electrons to form Mg plus 2 ion. Now when, since bromine is more electronegative than carbon, of course, so the bond pair, this bond is a polar bond where bromine is having some partial negative charge and C is having some partial positive charge. That electrons, bond pair electrons, are shifted more towards bromine, as bromine is more electronegative than carbon. Again, CH3 group, this CH3 group has some plus a inductive effect, that is bond pair repelling effect. So when this bond breaks to form CH3 plus, one of the electron goes to this carbon and making it neutral, that is CH3 plus, when gains an electrons, CH3 dot, non-paired carbon with an unpaired electron is formed, which is called a methyl radical. When the second electron comes to this carbon, then it forms CH3 minus ion. Okay, a single electron, one electron is added to the single electron, making it a double electron or bond or a negative charge. Then this minus, and in the reaction medium Mg plus 2 was also there, and bromide ion is also there. So Mg plus 2 is neutralized 2 charge, one of the 2 charge is neutralized by a bromide ion. So the one positive charge still exists, and the compound is CH3 minus Mg plus 2 Br, and this is called methyl magnesium bromide, and this is a Grignard reagent. So since CH3 minus is carrying a negative charge, so it must be a nucleophile, and it will react with aldehyde or ketone like nucleophilic addition reaction. Let's see what happens when methyl magnesium bromide is added to CH3Mg plus Br is added to formaldehyde HC double bond O, then H. Okay. Now carbonyl carbon is partially positively polarized and oxygen is partially negatively polarized. So here it is del plus and del minus, and this is a nucleophilic center where this CH3 minus comes to attack to this nucleophilic center and pi bonds are shifted to oxygen atom. The product is CH3 comes from methyl magnesium bromide, then this C with two hydrogen atoms CH2 and with a bond oxygen, with a single bond oxygen, and oxygen here having a negative charge as the pi bond is shifted over this oxygen atom. Now this negative charge is neutralized by Mg plus Br. So this compound is formed. Okay. Now when it is treated with water, or when water is added to it, water dissociates into H plus and OH minus. So H plus goes into there to neutralize O minus, and the main product is CH3CH2OH. So a primary alcohol is formed when Grignard reagent is treated with formaldehyde, and the byproduct is MgBr was there. Mg has a plus charge, so to neutralize that, which minus will be there, so the byproduct is MgOH and the main product is CH3CH2OH, that is ethyl alcohol. Okay, then what happens when Grignard reagent CH3MgBr is treated with acetaldehyde? Here I have taken formaldehyde and now it is acetaldehyde, CH3C double bond O, then H. So CH3 minus comes to the carbonyl carbon, pi bond shifts to oxygen. The mechanism is all exactly same, and the product is this CH3. Here I am writing this CH3, then this carbon has a H bonded, and here is a single bond oxygen with a negative charge, and a bond is formed with this carbon by the CH3 group. So the product is this, and O minus is getting neutralized by Mg plus Br, and when water is added, water dissociates into H plus and OH minus. So H plus is abstracted by this O negative to form CH3 CH, then CH3 OH. Okay. So this is the alcohol, and this alcohol is called a secondary alcohol. If the OH carrying oxygen is bonded with directly bonded with two carbon atoms, then this alcohol is called a secondary alcohol. And when the OH carrying carbon is bonded with a single carbon atom, then it is called a primary alcohol. Okay, so this is primary alcohol, and when Grignard reagent treated with formaldehyde, a primary alcohol is formed, and when Grignard reagent is treated with acetaldehyde, a secondary alcohol is formed. Now what happens when Grignard reagent is treated when treated with acetone? Okay, someone is Priyanshu is hi sir. Priyanshu is telling me, sir, a request hai, and I wish that's really a good lecture, sir. So what is the request, Priyanshu? Please tell me what is your request. Please write. I should respond. Okay. Then what happens? I'm discussing with you the nucleophilic addition reaction. Nucleophilic addition reaction of carbonyl carbon, that is of aldehyde and ketone. So now here we are here where the Grignard reagent is used to prepare an alcohol. When Grignard reagent is treated, you can see from these reactions, Grignard reagent is treated with the formaldehyde and along with the H2O, then ethyl alcohol is formed. Ethyl alcohol is a primary alcohol. When Grignard reagent is treated with acetaldehyde, then a secondary alcohol is formed. I am telling you what is secondary alcohol, which is carrying the OH carrying carbon is bonded with two carbon atoms. Now what happens when Grignard reagent is treated with C3MgBr is treated with acetone, C3 C double bond O CH3 acetone. Then what happens? Here still carbon is partially positively polarized and oxygen, this is partially positively polarized and oxygen is partially negatively polarized. As oxygen, I am telling you again, since oxygen is more electronegative than carbon, so the bond pair electrons are shifted more towards oxygen atom, making the oxygen partially negatively polarized or electron rich and carbon electron deficient. So a nucleophile CH3 minus carrying a negative charge is a nucleophile, should attack to this carbonyl carbon. So when this attacks to carbonyl carbon, the pi bonds totally shift to oxygen atom. Okay, so the product is CH3, then C, it becomes a single bond, O negative, then CH3 is also there, and again a CH3 comes from the methyl magnesium bromide or Grignard reagent. So CH3 bonded here. Now O minus is neutralized by Mg plus Beer, and then when you treat H2O, then H plus will be added to O minus to form this CH3, C, then CH3, here is also CH3 group and OH. So now this OH bearing carbon is bonded with 3 carbon atoms directly. So this alcohol is called a 3-degree alcohol. Okay, so the conclusion is that when Grignard reagent CH3Mg beer or CH3MgI or whatever is treated with formaldehyde, a primary alcohol is formed. When it is treated with acetaldehyde, a secondary alcohol is formed, and when it is treated with ketone, then what happens? Then a tertiary alcohol is formed. Now what is primary alcohol? Well, OH bearing carbon is directly bonded to a single carbon atom. This is primary alcohol. When OH bearing carbon is bonded with 2 carbon atoms directly, then it is called a secondary alcohol. And when OH bearing carbon is bonded with 3 carbon atoms directly, then this is called 3-degree alcohol. Okay, now what happens when Grignard reagent is treated with carbon dioxide? Let's see what happens. Now carbon dioxide, C double bond O, double bond O. So this carbon is del plus, this oxygen is del minus, and this oxygen is also del minus. So when CH3 group comes to attack this carbon, one of the pi bond gets detached and shifted towards oxygen atom. This pi bond shifts to this oxygen atom. Now the product is CH3, comes from here, CH3, then single bond to C, a double bond is also present intact, and this becomes a single bond O minus, and O minus will be neutralized by Mg plus Beer. Okay, now when H2 is added to this, H plus, H2 will dissociate into H plus and OH minus, then H plus will be abstracted from by this oxygen or O minus to form CH3, C double bond O, single bond OH. Now you know what is this? This is acetic acid. Okay, so when Grignard reagent is treated with carbon dioxide, acetic acid is formed. Okay, now what happens when Grignard reagent is treated with water directly? Grignard reagent cannot be kept in water. Why? Because CH3 minus and Mg plus Br, if you keep it in water, water will dissociate into H plus and OH minus, and the CH3 will combine with this H plus to form methane. Okay, so if you take Grignard reagent as ethyl magnesium bromide, then ethane will be formed. So any alkyl group will be combined with H plus ion, which comes from water to form alkane. Okay, now let's discuss about the reactions, Aldol condensation and Cannizaro reactions. Let's discuss the reaction between aldehyde and very dilute solution or 50% solution of sodium hydroxide. What happens? Let's see. Sodium hydroxide and first we take acetaldehyde. First we take acetaldehyde CH3, C double bond OH and 50% solution of NaOH, 50% NaOH solution. Now what happens? Okay, so sodium hydroxide being a strong base will dissociate into Na plus and OH minus. So a OH minus is there. Now this carbon is called carbonyl carbon and this carbon is called alpha carbon. The hydrogen bonded with this alpha carbon are called alpha hydrogens, and these alpha hydrogens are acidic in nature. Acidic means they can be released as H plus ion. Now which minus at first which minus is a base. It always try to show its basic nature, and since OH minus is also carrying a negative charge, it is also a nucleophile. But first of all, OH minus is a base, rather a nucleophile. Okay, so when acidic hydrogen is present, OH minus will surely act as a base, not as a nucleophile. I mean to say, here a nucleophilic center is present, but OH minus will not attack to this carbonyl carbon, rather it will abstract H plus ion from alpha carbon. Okay, alpha hydrogens are acidic in nature, that is they can be released as H plus ion. Why this is so? Because carbonyl carbon is partially positively polarized, oxygen is partially negatively polarized, and this methyl group has some plus inductive effect also. So these two effects acts in the same direction, making this carbon very much electron deficient, and that's why this carbon attracts the bond pair electrons from hydrogen atoms, and making these hydrogens some partially positively polarized. Okay, so some partial positive charge is there, and OH minus easily attacks to this hydrogen. Hydrogen leaves as H plus ion by giving up its bond pair electrons to alpha carbon. So here H plus comes, H plus combines with OH minus to form H2O. So H2O is released and a carbon ion is formed. The product is CH2, C double bond OH, and a negative charge, a bond pair electrons is shifted to this carbon, making it negative. Okay, so this carbon ion is formed, and when this carbon ion is totally a nucleophile, so it will get a nucleophilic center, it will attack to this carbonyl carbon, a nucleophilic center, and will make a bond with this carbonyl carbon. So the product is, I am writing from this carbon CH3, then single bond C, the pi bond shifts towards the oxygen atom. So a single bond, this is called, I told you, this is called electromagnetic effect. So single bond O minus, then hydrogen is there and a bond is formed with this CH2, then single bond C, double bond O, H. And ultimately you have to dilute you have to acidify the solution. When H plus is given, we minus subtract this H plus to form CH3CH, OH, then CH2, then C double bond O, then H. Okay, so this is the aldol product. Why this is called aldol product? Because this portion is aldehyde part and this is an alcoholic part. So aldehyde, ald comes from aldehyde and all comes from alcohol, ald plus all, making it aldol. So this product is called aldol product, and the reaction is called aldol reaction, and beta hydroxy compound is formed. This one is carbonyl carbon, this carbon is alpha carbon, and this is beta carbon, which is bonded to this beta carbon, which means hydroxy group is bonded with beta carbon. So this compound is called beta hydroxy, since 4 carbon atoms are there. So this compound is called beta hydroxy butyraldehyde. So this is the reaction mechanism, but how can we write it in very short time? The trick is CH3 C double bond to H, then again you write another molecule of CH3 C double bond to H. One of the alpha hydrogen is shifted towards the oxygen atom, and the alpha carbon bonded with this carbonyl carbon, and the product we write from CH3, then single bond C, then OH, here hydrogen is present, then a single bond with CH2, then single bond C, double bond O, then H. So this is the final product, and you can write it in just a short time. Okay, so this is the trick to form the aldol product. Now this is for today. Now tomorrow we will discuss, I will discuss with you some other aldol reactions and of course the Cannizaro reaction. Okay, thank you.